Okay, so I underlined the word evaluate just to kind of give you a little peace of mind here. You know how to evaluate things, right? We've done it a couple times before. So I'm going to show you that this is just a little bit, one of those like different things to show you here. Also want you to put like over here, if you have a different color, it would be helpful to kind of have a different color. Not a huge deal if you don't. Simple substitutions. So when we talk about simple substitutions, we can go all the way back to, I don't know, 4th grade, 5th grade when you first learned about variables. And when I said, say, maybe A plus B, what would that expression equal if A is -2 and B is 5? This is the most basic form of simple substitutions that there is, okay? And we've done this before. So that just means wherever you see an A, put what A actually is. Wherever you see a B, put what B actually is. So in these parentheses, I would say, okay, A is -2 and B is 5, and then you would just evaluate that expression. Evaluate means just do it. Just solve it. Do the math that is involved. And so that would be 3. You just evaluated an expression. Not with function notation yet. We'll get there. Okay? Another type of maybe evaluating expression is we did it on 3(1) and 3(2). Y equals 2x minus 1, right? So we're getting close to Unit 4. Unit 4 is going to have you graphing a lot of things. Actually, we did in Unit 3, right? Get the line on the graph. So you're going to be seeing y equals. I don't know if you remember last year, Mr. Meeks, did he teach anything about y equals mx plus b? Maybe a little bit. I know he didn't go into a lot of detail, but I've heard some of you say, oh, is that y equals mx plus b? So maybe you learned it last May. So we're getting into that heavy in Unit 4. So Unit 3 is getting you ready for it. So y equals 2x minus 1. And then the last test we took, I said, hey, here's a domain with, x equals -1, 0, and 1. I'm not doing that now. We're done with that, okay? But I am going to say to you, if x equals -7, what would the y value that would partner with that x value be, right? So you've done this. So you said, oh, if x is -7, then all I do is put it in there, multiply it by 2, subtract 1, and that's the y? Yep. Okay? Bless you. So we're not doing anything totally new just yet, right? I'm just kind of doing some simple substitutions, kind of easing you into this next one. So then the y value would be -14 minus 1. The y value would be -15 when the x value was 7. Yep. So if our goal is to create an ordered pair, and in that ordered pair, it usually goes x comma y, right? Because in this graph, I would have had -7 here, and I would have had -15 here. So what you would do is you would say, oh, so Mrs. Z said, make x -7. That's the given. And then find the other spot. Oh, so I did a little bit of math, and I found out that the y value that goes with it is -15. Done. That's simple substitution. Okay? The substitution is a little trickier when I give it to you this way. So let's say y equals 2x minus 1, except instead of giving you x, what if I gave you y? What if I said, okay, let's make y 5. Let's look at the difference between the math that we would have to do. Here, you're going to put that in there, and you got 2x minus 1. And right away, you notice something going to be a little bit harder, because instead of just doing a bunch of calculations, you have an actual equation to solve, right? So I have to say, okay, 5 is equal to 2x minus 1. This takes us back to 2, 1. Solving 1 and 2-step equations. 6 is equal to 2x. Divide by 2. So my x is going to actually be 3 when my y was 5. So if my answer goes in the form of an ordered pair, what was given, this is what I would suggest doing first. Write in what was given. The 5 was given. So what's your actual answer? This. So maybe even underline. So I'd like you to try to put your answers today on the worksheet that I give you. Your answers are going to be ordered pairs. The -15 is the most important. The 3 is the most important. If you can get them in the right order, great. It's not a huge, huge deal. Okay, so you're looking at me thinking, what the heck? What is new? We haven't really done anything new yet. So now it's time to talk about what function notation is. So I want you to write that. Function notation. Okay. Function notation is taking the y and replacing the y with something that looks like this. So nothing over here changes. Nothing in my 3x plus 2 or 2x minus 1 changes. It's just the y that changes. The y is being replaced with something that looks like that. And I want to talk very specifically about how you say that. That does not mean f times x. We have programmed our brains to think every time we see parentheses it means multiply. That does not mean f times x. I want you to actually write some quotation marks because these are the words that I want to come out of your mouth when you read that. F of x. So when you see that, the parentheses kind of mean of. And I know what you're thinking. Doesn't of usually mean times? Yep, but not here.
I know what the f in f is.
What is it?
Function of x.
Function of x. Yes, very good. So the function of x is equal to whatever. Very good. So f of x. So basically, this f of x just replaces the y. That's all it does. Here's kind of like a similar example of that. Back when you were in, I don't know, 3rd grade, 2nd grade, and they taught you, missing add-in facts. Box plus 3 equals 10. What goes in the box, boys and girls? And you're like 7, right? So you know that that's 7. What did they eventually replace the box with when you got to 5th grade or 6th grade? An x, right? So replace the box with an x, and it means the same thing. So we're replacing the y with an f of x, and it means the same thing. We're going to treat it like the same thing. There's going to be one little trick here. So now I want you to think about what that means, because the title of Unit 3 is Functions. Concepts of algebraic functions. So we don't use y in Unit 3, because that's an equation. We're talking about a function. So you know what that means? It means when I label my axes, I don't know why that's off, and usually I label it x and y. In Unit 3, we label it x and f of x. If I want to put an ordered pair, and it's usually x comma y, in Unit 3, when we're talking about functions, it's x and f of x. Seems weird, doesn't it? Okay? So f of x is just y. Okay? It's not always going to be f of x. You will also see sometimes g of x, h of x. You might even say k of t. You might even see w of a. You can see any combination. The most common ones are f of x, g of x, and h of x. Okay? But you're going to see some of these, and I want to show you how to work with them. Okay, so what does this mean? Everything I've showed you is just kind of like a prep for what we're about to do. And I do want to say one thing. I'm going to give you a problem. So let's say f of x is equal to negative 3x minus 5. And then I'm going to say semicolon. I want you to find f of x equaling negative 16. Okay, that looks crazy, especially because we just learned about f of x. And you know it's all about a simple substitution. I want to take you back to the first week of school, second week of school, when I gave you a sheet that had a bunch of smiley faces and bullseyes on it, right? And infinity symbols. You were like, what the heck is a smiley face doing on this, right? It said, if 8 smiley face 9 is equal to, A smiley face B, find... Right? And one of these was just, find A plus 2B. Right? So you had no clue what this meant. But about 30 seconds after I showed you, you were like, oh, that's it? Remember that? So all I needed to know was where to put the 8 and where to put the 9. Okay? Oh, because the A is in front of the smiley face and so is the 8. So all you're trying to tell me, Mrs. Z, is that that's a different way of saying A is 8? Yep. And because the B is after the smiley face and so is the 9, all you're trying to tell me is that B is 9? Yep. Why don't you just say that? Because SAT wants you to know it this way, right? Okay? So now that you know it, do you know where to put the 8 and you know where to put the 9? Yeah. This is the exact same thing. You only have two places that negative 16 can go. It could either go in for this whole thing or in for the x. That's it. Okay? So, what I want you to do, if you have another little, actually we can just do this. What is f of x really? Y. What are they telling me over here? I kind of like to just do like this. If the f of x is in a box and they're telling you that f of x is negative 16, then where should I put the negative 16? In for the f of x. So it's going to literally go right here. There's only two spots that you can put it. In for the x or in for the f of x. Well, it's f of x. So you know what I'm going to do? The 16 goes right here. And then I have my equals negative 3x minus 5. And then I have to just do a little equation and solve for x. But we know how to do that, right? Okay? So let's add 5 to both sides because that's how you work out equations, right? You cancel that constant first. That's going to give you what? Negative 11. And I know what you're thinking. Man, you can't do it. No, you can't do it evenly. So what? You got an improper fraction. So this answer can be left as 11/3. It can be made 3 2/3. You can make it 3.6 repeating. I don't care. Leave it like that. But if I'm asking you to say, okay, I know you got that as an answer, eventually I'll want you to know that when I input something, I want to know what the output is. So fill that in. So you know what I do first? I put in the given first. If this is x and the second spot is always reserved for that f of x, then where does negative 16 go? Is it negative 16 11/3 or 11/3 negative 16? The second way, right? The negative 16 was the f of x. That's the spot reserved for it. So this is the answer Mrs. E is really looking for. And to help me out, I'm going to even underline it so she can tell that that's the number that was found. Okay? So if f of x is given, then you put it in for f of x. Let's see what it looks like when it's the x that's given. Okay? So if I give you the problem, let's say p of x. Yeah.
Is the reason that the answer comes before 16 is because 11/3 equals x, and that's where the x value is?
Yes, okay. Yes. Did you guys hear what he said? He said, did you put the 11/3 there instead of there because this is the x value? Yes, because this is the x, and that was the f of x, which is the y, really. And the y always goes in that second spot. Okay, so if p of x is equal to negative 3x minus 5, find p at 7. That's how we say that. Find p at 7. Okay? And you'll see this a couple different ways. Sometimes they'll say, well, p at 7 is going to equal. So first of all, I got to figure out where to put it. Do I put it in for the p of x? Does it say p of x equals 7? No, it says p at 7. So here's kind of your shortcut. It's inside the parentheses, right? So if I go back to my original problem, what's inside the parentheses? The x. So that 7 goes in for the x in the equation, not the p of x. Okay? This is almost in a way so simple that it can get too complicated, so don't overthink it. If it's in the parentheses, what's in the parentheses? The x. Oh, so I'm going to put it right here and not in place of the whole p of x? Yes. So this, I'm going to show you this in a second. Negative 3 times x minus 5 if x is 7. So sometimes people will say p at 7, but then what I would like you to do is just to keep it that p of x. You'll see why. Show all your steps. Negative 3 times positive 7, which means p of x is going to be equal to negative 26. Okay? But I'm not done because I want to see if you can tell me what this ordered pair means. You got this far, you did the most important part. Yeah, it would be nice to put it in an ordered pair. So what was given? The x was given, so I'm going to fill what was given in first, and now I know where my answer that I just solved for is going to go. It's going to go right here, because look see it? It says it right here, p of x, which is really the y. which is the second spot, goes there. That's why I had somebody say, do I have to copy that P of X every single time? I think it's helpful when you do that, yeah. That's what you do when you solve an equation, right? Okay, yes?
How come that equals y, but the first one, the answer equaled x?
Okay, great question. He said, how come you put your answer here for this spot, but in this problem you put it in the second spot? I was given two different things in each problem, right? So in the first problem, I was given the f of x. I came right out and said, hey, f of x, which is really y, is negative 16, so I had to put it there.
Oh, okay.
Okay, makes sense? This problem, I gave you the x, so I had to put it here, and this is what I was solving for. It goes back to the front of, well, what are you solving for? Are you solving for x or are you solving for y? Okay? All right, good question. So let's do h of a is equal to 1/2 of a plus 4. Find, because it's, I can give you this problem. You can't do anything with it until I tell you what I want you to find, right? I want you to find h at a equal to 0. So if you are good with your calculations, the hardest part about 3 is going to be figuring out where do you put the 0. Do you put it in for this whole thing or do you put it there? So what I like to do is say it's not in the parentheses. H of a, which is really y, is equal to 0. Where is y usually? Here. So this is going to go right there. And 0 goes there. Are we good? Does that make sense? Okay. So if h of a is 0, 0 is equal to 1/2 a plus 4. 0 doesn't mean stop. It doesn't mean no solution. It means keep going as long as there's still a variable there to solve for. Cancel this out. The constant first. 0, take 4 away, gives you negative 4. This brings up a great question, a good review. When my coefficient, I need to get rid of it by doing what, Joel? Or did you have a question?
I was going to ask a question until I realized what you were doing, and then I...
Yes. Okay. So you're good? You answered your own questions. Awesome. So I would normally divide, but I don't want to divide by a 1/2 because then it messes with it. So what would I do?
Multiply by the reciprocal?
Yep. Multiply by the reciprocal. And what is the reciprocal of 1 over 2?
2 over 1.
2 over 1, which is just 2. So I'm going to multiply by the reciprocal. Negative 4 times 2 is negative 8. And that's what A is. Because think about this. What this means is, hey, I'm thinking of a number, and I take half of that number. And I get negative 4. A lot of people want to say it's 2 because they see a half, and they think half of 4 is 2. I'm not asking you to take half of 4. I'm saying take half of a number, and you get 4. Well, didn't it have to start out as 8? Okay, so now let's do this. I got to figure out, is it 0, negative 8, or negative 8, 0? Well, what was given? H of a was 0, and that's in the y spot, so that goes there. And then your negative 8 was given. So help me out a little bit by underlining it so I know which answer to really look for. Okay, are we okay so far? Okay, I'm going to show you 2 more problems, and then that's it. So it's really all you have to know is where do I put it. So we're going to do one with some exponents because we need a little practice on those, and one with some parentheses, okay? So let's say k of n is equal to 3n squared plus 1. And I'm going to ask you to find k at negative 1. Just got to figure out where do you put the negative 1. Does it say k of n is negative 1? No. So don't put it in for k of n. Is it in the parentheses? Yes. And what's in the parentheses? N. So I should put it in for n? Yes. Arrows, not necessary. Just if you need a kind of flow chart where to go. So k of n is really going to equal 3 times n squared plus 1. And n is negative 1. Let's go back to like September 14th or 15th or 16th, second week. Can I just do 3 times negative 1 and get negative 3 and then square negative 3?
No.
Not if you want to follow the order of operations. So I should do the exponent first. So I should take negative 1 and square it, which, by the way, is not negative 1. It's positive 1 because there are 2. So k of n is going to equal 3 times 1 plus 1. K of n, this is me like showing like every possible step. You do not have to show every possible step, but could you at least do, like, maybe get to this step and go right from here and get 4? Okay, the more steps you show, the less likely you are to make a calculation error. So let's figure out my ordered pair. Is it -1, 4 or 4, -1? This was what? Oh, and here's what's, I know you're thinking, what do you mean what is x? You're giving me k's and n's. What the heck? Well then, you know what always goes in the first spot? The n and then the k of n. So that's the y. Is that what was given? No. So that's the first spot. So the -1 was given. The 4 is what I found. Are you with me? Because I have one more example to do with parentheses, and then that is all for this section. Okay? All right, let's do these parentheses. So let's take w of t is equal to -3t plus 2 times t minus 3. All right, I got to know what I'm asking you to do. I'm asking you to find w of t equals -5. The hardest part of this whole thing is where do I put the -5? You only got 2 spots. Is it t or is it w of t? So w of t is -5, so you're going to put it in for that whole thing. Right? Because it's not in the parentheses. If it was in the parentheses, that would be t. So -5 is equal to I didn't mean to, well, let's just finish it. I meant to give it to you, this spot, but let's just keep going. Let's see what it turns out to be. I meant to give you t, but that's okay. All right, we're going to do it 2 ways. Just keep going. So if I have the -5 over here, normally I look to see what's in parentheses first and I combine it if I can, but I can't because t and -3 are not like terms. So I have no choice. I have to do what? Distribute, right? So this gets brought down. 2 times t is 2t. 2 times -3 is -6. This isn't so bad. -5 is then equal to what's this? -3t plus +2t is -1. I'm actually glad this happened because I want to point something out. Cancel the constant. This gives you 1. I had a lot of people on their retest leave the answer like that. You didn't finish the problem. I asked what is t, not what is the opposite of t. So that's the same as having a 5 or a 7 or any other number in front of it. There's a -1 there. You're not done. Divide by -1. And so -1 is actually equal to +t. Okay? Now, I want to do this exact same problem, except instead of finding w of t equal to -5, I want you to find w at 2. Okay? So do you see how this changes the problem? Keep this exact same problem, except now you're finding when t is 2, because it's in the parentheses, right? What's in the parentheses? T. So where's the 2 going to go? Here and there. So let's do it this way. W of t is equal to -3 times t plus 2 times... Okay, this is actually, I'm glad this happened. Because I want you to see last time I couldn't combine. This time I can. So take care of those parentheses first. W at t, I got to do the answer key for this, or the ordered pair. Can I go ahead and just multiply these two real quick? Because it's kind of separate. It's saying subtract these, multiply this by 2, then add it to that product. I'll say that again. What this is asking you to do is find this difference. Whatever that difference is, multiply it by 2. And then when you're done with that, add it to this product. There's a lot of vocabulary words. Let's just do it. -6 plus, and I had a lot of people distribute, and not necessary. Just do 2 times -1. And then I had a lot of people say, I'm just going to do this -2 plus, or -6 plus 2 real quick and get -4 and then multiply the -4 by the -1. Nope. You cannot do addition before you do multiplication. So W of t, I know it's a pain in the butt, negative 6. Now you have two options right now. What's a positive 2 times a negative 1? Negative 2. Watch how I'm going to write it. I'm going to write it like that. Some people might say, nope, I got to take and add, because what's a they might look at it as positive 2 times negative 1 and do this. I'm trying to get you to look at it this way. I guess I don't really care as long as you get negative 8 somehow, right? Okay, yeah.
Wait, aren't you supposed to put negative 5 equals and then the problem? Or...
What do you mean negative 5? Oh, yeah. So that's what I was going to say. So we just did two different problems, right? So this problem is 1. Let's go back up to the original problem that I was moving so quickly to get through to get to this one that I didn't do the ordered pair for it. So ignoring this right here, what was given in the original? W of t. So where does that go? And when I found that W of t was negative 5, what did t work out to be? Negative 1, right? So what's the ordered pair for this one? This time I gave you the t, because that's what's in the parentheses. When t was 2, what did W of t work out to be? Negative 8. All right? See what I mean about it's just a matter of knowing where to put the value. And once you do, you go from there.